Entities like RIT registered for and received their own ASN, Autonomous System Number. They became autonomous systems of their own, independent of ISPs. This allowed them to maintain routing tables and exchange routing information with multiple ISPs. As traffic is ready to leave the autonomous system, the routers decide which ISP and which ISP connection to send the traffic to for the most efficient packet delivery. At home, we don't have to exchange any information about networks with our ISP. There is a default route in our router that basically says any traffic for anywhere but my local home network, send it to the ISP's router. Why would we want the overhead of exchanging routes? If the connection to our ISP goes down, we're not sending any communication off our network anyway. Besides, our home routers don't have the memory or processing power for 750,000 routes. However, inside a company, within an autonomous system, there needs to be a dynamic way in which the routers can exchange information about the internal networks, as well as how to get to the company's edge router that connects to the ISP for packets destined for an external network. This is where routing protocols come into play. An IGP, Interior Gateway Protocol, is a routing protocol that allows routers within an autonomous system to communicate with each other, sharing information about the networks they're directly or indirectly connected to. After these messages are passed between the routers, each router forms an idea of the topology and determines the best way to get to a destination network. Metrics are values that the routers use to determine the best way to get to a destination network when there are multiple paths available. Nowadays, the two main IGPs are OSPF, Open Shortest Path First, and Cisco's EIGRP, Enhanced Interior Gateway Routing Protocol. The main metric used by OSPF and EIGRP to determine the best way to get to a destination network is bandwidth, although they calculate this metric very differently. Using OSPF or EIGRP, a router might choose a path to a destination network with more hops over a path with fewer hops based on the bandwidth. Sending a packet over a greater number of links is preferred if those links and their bandwidth can get the packet to its destination quicker than a smaller number of links. We make these decisions all the time ourselves. Sometimes I'd rather drive more miles on the highway to get somewhere quicker than less miles on local streets with fewer lanes, traffic lights, and a lower speed limit. An EGP, Exterior Gateway Protocol, is a routing protocol that allows routers from different autonomous systems to communicate with each other and exchange routing information. The only EGP in usage today, which is used across the entire internet, is BGP, Border Gateway Protocol.